1.7 Linear inequalities. Use graphs to find this set. Okay, so before what we did is we started with an equation. We solved the equation, we graphed it, and then we would go to set notation. Now we're going to utilize set notation to find it. Okay, so parenthesis -3, so we go over here to -3 right there, and we're going to have a parenthesis opening up. Then it's going to go all the way to +2, so +2 is right here, again, a parenthesis, and then it would be in between both of those. Let me do the colors again. That'll be helpful. So right here, this is what we have, colors, right? Okay, so let's try blue. So blue, we have -2 right here, -2, bracket, and then it goes all the way to 8, bracket, and then we just fill everything in between, right? Okay. Now, because we have this intersection symbol here, right here, this is like the and that's the intersection. Okay. So what that means is we're only interested in from here to there, where they overlap. And it looks like they overlap from there to there. So they're going to overlap from, it looks like, the -2, and they keep going on all the way into the +2. The -2 has a bracket, but the +2 has a parenthesis. Okay, so hopefully that makes sense. Now let's try the next one. Okay, so -5 is right here. We have a parenthesis next to it. Goes all the way to a +2 over here. +2 has a parenthesis next to it. We shade it in. Then we have a -3, which is right here, which uses the bracket. Then it goes all the way to a +7, which uses a bracket. And then we just fill all this in. Okay. Now in this case, though, notice that we have the giant U symbol, and that's the union symbol, okay? So that's the OR, and that's the union symbol. So we're interested in everything that's shaded in, which in this case will just be everything, right? So we're going to start with the parenthesis -5, and we're not going to stop until we get to the 7 bracket. So we include everything. Okay, let's try the next one. So we're going to start with -infinity, which is over here somewhere. -infinity. And it's going to go all the way to -1, which is over here. So parenthesis there, and then just shades. Shade, 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 shade. All right. Okay, we did the first one. Now let's shade in the second one. It's going to start at -3 right here. But this one is going to have a bracket. And it's going to open up to the right and keep going until it gets to a 2. And we have a parenthesis on the 2. Now this one goes back to the intersection and intersection, right? So again, and intersection. So we care only about the part that overlaps. And the part that overlaps looks like it's somewhere between here and here's the interlapped, right? So it looks like it starts at -3. The bracket -3 goes all the way up to -1 parenthesis. And that's where that one ends. All right, so we want to use the integral notation to express the solution set and graph the set on the number line. Okay, so we're just going to finish solving this. -4, -4, cancel, cancel, 2x is less than. 10 minus 4 is 6. Divide by 2, divide by 2, cancel, cancel. X is less than 3. So we're going to go over to 3 over here. It says x is less than 3 plus, so less than is to the left. And the little arrow right here, it actually points to the left. So it should open up as a parenthesis to the left. So use interval notation to express the solution set and graph the solution set on the number line. And once you get x is less than 3, you can write this in interval notation. All right. So what we would do is we would, if you keep going over to the left, you end up with -infinity. So we start with -infinity on the left, and we go all the way up to 3 with a parenthesis. Next one. we are going to divide both sides by a -3. By dividing both sides by a negative, we flip the inequality from greater than or equal to less than or equal. And 30 divided by -6 is -5. We go -5 over here. X is less than or equal, so it is a bracket, and then it opens up just like that. And if you keep going to the left, you do end up with -infinity, -infinity, and you go all the way up to a -5, but this time with a bracket. Next problem. So in this one, we're trying to get the 9x by itself, so we undo the subtraction of 13 by adding 13. Whatever you do to one side, you do to the other. Those cancel out, leaving 9x is less than or equal to 2x. So bring down the 2x, and then we say -14 plus 13 would give me a -1. Now I want to get the 2x, the positive 2x over here on the right. I want to get rid of that. So I'm going to subtract 2x. Whatever I do to one side, I do to the other. Those cancel out. 9x minus 2x is 7x, and that is less than or equal to a -1. Next, we undo the multiplication of 7x by 7 by dividing by 7. And we say x is less than or equal to -1/7. Now we can plot the -1/7 to be a little bit less than 0, right about there. And it's less than, so it's to the left, and it has the equal part, so it is a bracket. So just graph all that in there. Okay, now we want to write that in interval notation. So it's understood there's a -infinity over there to the far left, so we write the -infinity, and it goes all the way up to -1/7, and we use a bracket next to it, just like we had right here, and because we have an equal right there, so we know we have a bracket next to it. Well, let's try the next one. There's no fractions or decimals on this one, so we're going to move to distribution. So we said 7 times x is 7x, 7 times 1 is 7, plus 3 greater than or equal to, we keep the 6x plus 17. After distribution, we combine like terms. We have a 7 plus 3, which gives me a plus 10, which is greater than or equal to 6x plus 17. Next, we get all the variables on one side, minus 6x, cancel, cancel. 7x minus 6x is just x, plus 10, greater than or equal to 17. Next, we get all the constants on one side, minus 10, cancel, cancel. X is greater than or equal to 7. So we plot the 7 over here. X is greater than or equal, so it points over to the right. And because it has the equal part, it is a bracket, so we just shade that in. Going to the right infinitely, there's a positive infinity over there. So you write the interval notation as 7 within the parenthesis to positive infinity with a parenthesis next to the positive infinity. Let's try the next one. So in this case, we do have fractions. So first step is to get rid of the fraction. We have a 2, a 6, and a 3. The least common denominator of a 2, a 6, and a 3 is going to be a 6, right? So you could count multiples of 2, 2, 4, 6. 6 is, 6, 12, 18, but 6 is there again. And you can do 3, 6, 9, again 6. So the least common denominator, or least common multiple, is going to be a 6. So we multiply the whole thing by 6. Okay? You can think of these as canceling out, right? 6 divided by 2 is 3, 3x. 6 divided by 6 leaves me a -1, right? Oh, so we distribute it. And then over here, 6 divided by 3 is a 2, leaving me 2x. And 6 times 1 is 6, giving me a positive 6. Now at this point, I'm going to get all my variables on one side. Minus 2x, cancel, cancel. 3x minus 2x is x. Next, we want to get all the constants on the other side. So we have x is less than or equal to 7. We plot the 7 over here. We say x is less than or equal to that, so it's a bracket. And we just shade it in. Okay, it's understood there's a -infinity over there to the left, so we have -infinity to 7, like that. Let's try one more. Other than empty set, use interval notation to express the solution set and graph each solution set on the number line. Okay. Let's see. So we want to get our variable, which is the -1/2. We're going to get that by itself, but first let's get rid of the 2. So we get rid of the denominator by finding the least common denominator. There's only a 2, the fraction's 2, so we multiply everything by 2. So 2 times 4 is 8. 2 times x divided by 2 is just -x. and then 2 times 8 is 16. We get the negative x by itself by subtracting 8. Whatever we do to one side, we do to the other, leaving me negative x is greater than 16 minus 8, or 8. Then we undo the multiplication of x by a negative 1 by dividing by a negative 1, and whatever we do to one side, we do to the other, leaving me x is, because we divide both sides by a negative, we flip the inequality, and 8 divided by negative 1 is negative 8. We plot the negative 8 over here, and we say x is less than negative 8. So we have a parenthesis opening up towards the left, which is less. We have a negative infinity right there. So this is going to be negative infinity all the way up to negative 8, parenthesis next to the negative 8 and the negative infinity. And that's that.